Okay, so trig identities and the sum and difference formulas. So this lecture covers section 5.1 and 5.2 that is in the book, and the book is in my math lab if you look for it there. So we have some trig functions and some relationships among them. Basic functions are cosine, sine, and tangent. Tangent can be defined in terms of sine and cosine. We have reciprocal functions. Secant is 1 over cosine, cosecant 1 over sine, cotangent 1 over tangent. We have a Pythagorean identity, sine squared plus cosine squared equals 1. If I take this one and divide by cosine squared, right? So sine squared plus cosine squared divided by cosine squared, we get the second one. If I take the first one and divide by sine squared, you get the second one. And finally, we have some even odd identities. Cosine and secant are even, all the other trig functions are odd. So that means cosine minus t is the same thing as cosine t. Secant of minus t is the same thing as secant t. Sine of minus t is minus sine of t. Tangent of minus t is minus tangent of t. And then finally, if we have two angles in a right triangle, the cosine of one, right, the cosine of s is adjacent over hypotenuse, but the sine of t is also opposite over hypotenuse. But the adjacent for s is the same thing as the opposite for t, so we have these relationships between cosine and sine. So the point about trig identities is, in verifying trig identities, is that these are the basic things that we need to know about sines and cosines. How do you learn to master these things? How do you remember them? Well, use them, right? You learn about things by using them. So with these properties, we can verify lots of other types of identities, right? So example 1, verify that secant of x times cotangent of x equals cosecant x. I'm putting a question mark here because we don't know if this is true. If we know the equality is true, that'd be great, but we don't. So how do you verify something? Take one side and turn it into the other. So this is the left-hand side, so we'll call that LHS. This is the right-hand side, we'll call that RHS. So my left-hand side is equal to secant of x times cotangent of x. So how can I simplify that? Well, secant and cotangent, I'm not too familiar with that. So one way you can deal with this, turn everything into sines and cosines. Right? And that's one way to go about dealing with these things. So secant we know is 1 over cosine x. That's one of the reciprocal relations up top. Cotangent x is 1 over tangent, and tangent is sine under cosine. So there's my secant and cotangent, and they're just part of the reciprocal identities that are listed above. If we cancel out the cosine there, we're just left with 1 over sine x. So we've done a little bit of simplification on the left side. We want to end up with cosecant x on the right-hand side, but we look at 1 over sine, we look at our reciprocal functions, and we can see that 1 over sine is cosecant of x. Okay, so, and that's the right-hand side. So we have in fact verified this because we turned one side into the other side. So this is one thing that is a useful tool to do, turn things into sines and cosines and see what you can get. So again, we're just using these identities to try and get relationships between other equations. These identities are the ones that we really want to be grounded on, so we want to be able to see them in action in a sense. So verify that cosine x minus cosine x equals cosine cubed x. So the left-hand side is more complicated than the right-hand side. I didn't know what to do with cosine cubed, so we'll start with the left-hand side. And that's equal to cosine x minus cosine x times sine squared of x. There's a couple of things we can do, but one is, remember some algebra, you can always factor, right? And that comes up in a couple of different cases. So we can factor out the cosine x. Remember that this cosine x here, that's 1 times cosine x. So when I factor out a cosine x out of this term and out of this term, we'll be left with a 1 minus sine squared x. That's my left-hand side. Can I simplify this a little bit? As it turns out, yeah, anything with a squared so trig function squared think Pythagoras, right? A squared plus b squared equals c squared. So we can actually come up here and you look at the Pythagorean identities, the one at the very top. Sine squared plus cosine squared equals 1. So sine squared x plus cosine squared x equals 1. Well, if you subtract the sine squared from both sides, you get 1 minus sine squared x equals cosine squared x. So this thing here is just cosine squared x. So we get cosine x, that's this, times cosine squared x, and that is in fact cosine cubed x, which is our right-hand side. So we've done our identity. So factoring the usual algebraic things, factoring, but also if you see trig function squared, think about Pythagoras. What about this thing? Well, secant x, tangent x, 1 plus sine x, cosine x. Fractions like to be simplified if you can. So we'll start with the left-hand side, and we'll say that this is 1 plus sine x over cosine x. What do we do with a plus there? We can break this into 2 fractions. Frac. That's supposed to be an A. 1 over cosine x plus sine x over tangent x. And if you remember our reciprocal functions, 1 over cosine x is secant x, and tangent x is sine x over, well, should be cosine x there. So that just straightens out like that. And so again, by doing these identities, you know, you'll start remembering that 1 over cosine x is secant x, sine x over cosine x is tangent x, and can work through some of these things. Sine x over 1 plus cosine x equals 1 minus cosine x over sine x. Remember, we don't know this is true, so we can't cross multiply because we don't know that there's an equation here. We need to turn one side into the other side. We can't mix terms from different sides of the equality because we don't know that the equation is actually true yet. You have to verify it first before you can do that. But if we were going to do some cross multiplication, we would think about multiplying the left side by sine x, for example. So left-hand side, right? If we were going to do cross multiplication, we'd have to multiply the left side by sine x. So let's think about just multiplying the left side by sine x over sine x. And what's that equal to? Oops, times the left side sine x over sine x, sorry, 1 plus cosine x, because that's my denominator. And this becomes sine squared x over sine x times 1 plus cosine x. Okay, so I don't want to cancel out the sine x's because that's just what I've, multiplied in, right? So it looks like that can cancel, but that's not going to help me that because we just started that. But sine squared x plus cosine squared x equals 1. So what can you do there? Well, sine squared x is 1 minus cosine squared x. Does that help me? Well, you have to be able to use some of your algebra skills. That's a thing that can be factored. 1 plus cosine x times 1 minus cosine x. Oh, and I really ran out of space there, didn't I? 1 minus cosine x all over sine x times 1 plus cosine x. But that means this and this can cancel out, and you're left with 1 minus cosine x over sine x, which is what we wanted. So algebra properties like factoring, it's just 1 minus cosine squared x, 1 minus something squared x, difference of powers, so you can factor it. Again, something trig function squared, think Pythagorean theorem. Okay, what about this one? Well, got two terms there, right? Two fractions. What do you do with two fractions? Find a common denominator. So left-hand side, we'll take the first term and we'll multiply it by cosine x, 1 minus cosine x, 1 over 1 plus cosine x, right? So the denominator here, take it over itself and multiply it by this term, and then we'll take this term and multiply it top and bottom by the denominator of this term. So that looks pretty grim. But what do we have? We've got now a common denominator, which is 1 minus cosine x times 1 plus cosine x. And on the top, we have 1 minus cosine x, that's from here, plus 1 plus cosine x. So that's convenient, actually. These two cancel out. And so this becomes 2 over 1 minus cosine x times 1 plus cosine x. Great, so what does that become now? That becomes 2. I can multiply this thing out in the bottom. I get 1 minus cosine x plus cosine x, first outer, inner, last. Plus cosine squared of x. And these go away, and I'm left with 2 over 1 plus cosine squared x. But I screwed up a sign. This is supposed to be a minus. So that becomes a minus cosine squared x. And so finally, we're left with 2 over sine squared x. Okay, but we know that sine squared x, 1 over sine squared x, is the same thing as cosecant squared of x. And we have a Pythagorean identity involving cosecant. Cosecant squared of x is equal to 1 plus cotangent squared of x. And that gives us what we're looking for. So, there's a little bit of work there, but when you're dealing with two fractions, pull them together over a common denominator. Multiply things out. That's another thing you can do just because of algebra. And then again, when we're thinking about having something squared, think about Pythagoras. Something squared, you can do some kind of a Pythagorean thing. So reviewing this, what's going on when we're dealing with identities is you have these basic set of identities here. And we want to be able to recognize them when we're playing with, when we're using various functions, right? And so this is sort of, can you see how these things might relate? Can you play with these rules to turn one side into the other side? We have rules from algebra that it's important to remember. Factoring, breaking a fraction into two pieces, pulling together two fractions into one. A major thing is, well, factoring again, is recognizing that anytime you have a function squared, a trig function squared, you're probably looking at some kind of Pythagorean identity. And then the reciprocal identities, right? You have to be quick at recognizing, or learn to be quick at recognizing secant and cosecant and cotangent. Okay, so sum and difference formulas. Here are the sum and difference formulas for sine and cosine. I'm going to draw this out, where these come from. You don't need to copy this down if you don't want. It's just sort of, here's where these two things come from. So suppose I have one angle that I'll call S, and we know at this point here, we'll call this part along the x-axis x1 and y1. And that tells me that x1 is cosine of S because it is the x-coordinate, it's the adjacent, y1 is sine of S. It's the opposite. And this is the unit circle, right? So my hypotenuse is just 1. So suppose I have another angle, and we'll call this angle T. And I can finish off its triangle. So we'll call this distance x2, and then this height is y1. x2 is cosine of t, y2 is sine of t. And then if I add the two angles together, I get another angle, which, you know, I'm not entirely sure where it would be, but we'll put it here. And this whole angle here is S plus T, from here all the way down to there. And so these 2 points, right, if we draw this triangle, this is x3, and this height here is y3, and x3 equals cosine of the two angles added together. Y3 equals the sine of the two added together. Okay, what I want to know is what is the sine and cosine of this angle in terms of the sine and cosine of the two previous ones. And here we're going to get a little bit tricky. We're going to take this point, which is x3, y3, and we're going to draw a perpendicular line back down to this angle so that that's a right angle. So this is a right angle. This is a hypothesis of 1. So what angle is this angle here? Well, that angle there is, well, this is t. This whole angle is s plus t. So t plus s. This angle here, this little wedge here, that's got to be s. And this is 1. So this has to be, this length here, that has to be cosine s. This is the adjacent. That's x1. That means that has to be y1 because it's opposite. So I have a triangle here. This triangle here is the same as this triangle here, although they're not the same size. Just rotated around a little bit. Okay, so if that's s, x1, y1, we still want to figure out what x3 is. So now I'm going to add yet another triangle by coming from this point over. Great. I know its hypothesis is y1. What's the angle inside that triangle? Well, if I continue this line out that way, we've got this line cuts through here. This line cuts the x-axis with an angle of t, so this angle has to be t. If this is a right angle, then this angle has to be 90 minus t, which means that that angle is t. Great, so we know the angle at the top, we know the hypotenuse. So what is this side? That's the cosine of t times this hypotenuse, right? And cosine of t we're calling x2. So this is x2 times y1, that's this height. This side is the opposite from the angle t with a hypotenuse of 1. So that side is y1, because that's my hypotenuse here, times the sine of t. So this length here is going to be y1, which is sine of s times y2. y1 times y2. Great, now we've got the picture all set up. What is x3? That means we're looking for this x-coordinate. How do we get that? Well, we go up here and then up here. So what's our change in x? We went, oh, I forgot even another triangle. Shoot, I needed one more triangle. Now you see why I'm not making you draw this out? This is angle t still. This is hypotenuse of x1, which means this part here is x1 times cosine t, which is x1 times x2. And this height here is my hypotenuse x1 times sine of t, so that's x1 times y2. There we go. So to get from the origin to this point, to get the x-coordinate, we go right x1 times x2, and then we subtract off y1 times y2. And to get from the origin up to this point, what's our height going to be? What's our y3? Well, we go up to this point and then up again. So our y-coordinate, we go up x1, y2, and then up x2, y1. So y3 is x1, y2 plus x2, y1. And if I zoom out a little bit, that's our two formulas. Cosine of s plus t, that's my x3, is cosine cosine, so x1, x2, minus sine sine, minus y1, y2. Sine of s plus t, that's a y. Sine of one times the cosine of the other, x1 plus y2, plus sine of one times cosine of the other. Okay, it's a messy picture, so I didn't mean that you wouldn't draw it, but it's good to know where those formulas come from. It's a nice exercise in geometry, actually. So what's the exact value of sine of 75 degrees? Well, we know that we have this formula. So sine of s plus t equals sine of s cosine of t plus sine of t cosine of s. So 75 degrees, what are the angles that we know the sines and cosines for? 30, 60, 90, root 3 over 2, 1/2, and 1, and 45, 45, 90, where all the sides, these two sides are 1 over square root of 2. And that's 1. That's really what we know. So what do we know about 75 degrees? 75 degrees is 45 degrees plus 30 degrees. And we know the sines and cosines of both those angles because we know these triangles. So sine of 75 degrees is sine of 45 degrees plus 30 degrees, which is sine of 45 degrees cosine of 30 degrees plus sine of 30 degrees times cosine of 45 degrees. But we know all these numbers. This is 1 over square root of 2. Cosine of 30 degrees is 1/2. Sine of 30 degrees is root 3 over 2. Cosine of 45 degrees is 1 over square root of 2. So there's the sine of 75 degrees. 1 plus square root of 3 over 2 root 2. So we can also get difference formulas. Cosine of s minus t is this, and we get that by using even odd identities. Cosine of s minus t is cosine of s plus minus t. If we apply the cosine formula, we get this, but cosine of minus t, cosine is even, so cosine of minus t equals cosine t. Sine is odd, that means sine of minus t equals sine of t, right? And so this minus sine and this minus sine get together to make that a plus. Sine of s minus t, same procedure. S minus t is s plus minus t, so you get this by plugging everything into the formula, and then you get sine of s cosine t minus sine t cosine t, because that minus sign comes out, because sine is odd, that minus sign goes away, because cosine is even. So what's cosine of 15 degrees? Well, 15 degrees we recognize as being cosine of 45 degrees minus 30 degrees. So according to our difference formula, there should be cosine of 45 times cosine of 30 plus sine of 45 times sine of 30. And from our various triangles, we know that that's 1 over root 2. Cosine of 30 is 1/2. Sine of 45 degrees is 1 over root 2. Sine of 30 degrees is root 3 over 2. So we get 1 plus root 3 over 2 root 2. So the cosine of 15 degrees and the sine of 75 degrees turn out to be the same, which isn't that surprising because 75 plus 15 is actually equal to 90. They're complementary angles, so the sine of one should be the cosine of the other. Okay. So then you can also rewrite certain things. If I've got cosine plus sine, sine, which formula am I using? So cosine plus sine, sine, that must be this one. So this must be equal to cosine of pi over 7 minus pi over 3. Which is cosine of, if you put over common denominator, 10 pi over 21, which is about 0.7 something, I believe, 0.075. So you have to recognize this as being cosine of s minus t. There's a plus sign, cosine, cosine, plus sine, sine. And that's what the formula for cosine of s minus t is. And they have s as pi over 7 and t as minus pi over 3. Right? And so you can condense that into one trig function. We know the identities for sine and cosine, so we can find it for tangent. So what's tangent of s plus t? Sine of s plus t over cosine of s plus t. And then we use the formulas for sine of s plus t to get this, right? So we just take this and plug it into the top by using the formula. Same thing for cosine of s plus t in the bottom. How did I get from this formula to this formula? Divide top and bottom by sine s times sine t, right? And that'll leave you with a cosine t, no, shoot, sorry. Don't want to divide by that. I want to divide by cosine s times cosine t. And then that would give you, if you divide this by cosine s times cosine t, the cosine t's cancel out. You're left with sine s over cosine s. So there's our formula for tangent of s plus t, tangent of s minus t. The tangent addition formulas and subtraction formulas don't come up that often, but they're useful to think about. So what is the tangent that we're looking at here? Right. Well, I've got a plus and I've got a minus. So plus and minus, that's this formula, right? Minus on the top, plus on the bottom is the difference. So this should be a tangent of something plus something, and the two angles I have are pi over 4 plus pi over 6, right? And that gives me tangent of something over 12. 5 pi over 12, whatever that happens to be. So, yeah, and so we can express that as one tangent. So, and here's the list of the sum and difference formulas. So the best way to get to know how to use your tools is to use them, right? Here's the tools, sum and difference formulas, and a bunch of tools that are basic identities. They're useful, many of them are useful to use, and so you use them by doing these sorts of problems. And when you get into calculus and more advanced things, these kinds of things will come in very, very useful.